Kim and Helen compete with 3 other students. So how many people? 5 students. There are 5 students. Be careful about that. To get the highest grade in the class, what is the probability that Kim will get the highest grade and Helen will get the second highest grade? All right. Now, how many events are there? There are 2 events. Is it an and or an or? And. So, for Kim to get the highest grade, how many choices do we have for the highest grade? We have 5 people. And when I say Kim is getting it, how many Kims are there? There might be multiple Kims, but this Kim in particular, there are how many? 1. Now, for the second one, to get second place, do we still have 5 available? No, because it's the second place, first is taken. So isn't this 4? And how many people do we choose from to have a Helen? 1. So your answer is 1/20. That's it. Now, here's another way of doing it. Let's do it all at once. Let's think of permutations. There are 5 people. How many ways can you order 2 people out of 5? Because aren't you ordering 2 out of 5? And aren't you ordering them first, second? 5P2. There are 5P2 ways to order 2 people out of 5. Now, I can order 2 people out of the 5. How many of those orders do I want? I want 1. Who do I want first? I want Kim and then Helen. Out of these choices, I want 1 way. Now, what's 5P2? Isn't that 5 times 4? They both get the same answer. So you could either just think of 2 events, or you could think of it as, oh, if I order the 5 people, if I order choosing 2 people out of 5 and then choose the 1 I want, that gets it 2. It's your choice of how to do it. Number 2. Jason, Jose, Hans, and 4 others. How many are there? 7 people. Are left in a drawing for 3 DVDs. What is the probability that those 3 guys will each win a DVD? So, there are 3 events. Is it and or? Aren't you them and then and they're ands? Now, for the first one, what's the probability of one of these guys, one of these 3, getting a DVD? How many are there? 7 to choose from, and how many people out of the 7? How many of these 3 people can I choose from? I have 3 people out of the 7, correct? I want one of these 3 to get it, correct? So I have 3 out of the 7. For the second one, now, I have 6. Are you okay with that? There are 6 people left to choose from. And I want how many possible? 2, because I have 1 less. I have him 1 already. He won already. One of them won. Here, there's 1 less here and 1 less here. And for this one, what's going to be the last one? Aren't there 5 people left to choose from? And don't I have 1 of what I want left? I have Hans or whoever it is. Now, if I multiply all those, there might be an easier way, especially, watch right here. Doesn't this cancel with this, leaving you 1 and 3? And then can't the 3's cancel? So it looks like my answer is 1 on top and 7 times 5 on the bottom. You have a 1 in 35 chance. Now, the other way is this. Isn't this a combination? You're choosing 3 people out of 7. If I simply do 7C3, I can choose 3 people out of 7. 7C3 tells me how many ways I could choose 3 people from 7. And I want 1. I want one of those ways. That one way of choosing is Jason, Jose, and Hans. I want those 3 guys. So how many groupings of 3 out of 7 can you make? And then I want this group of people, that one group of people. This would get the same answer because you got to think about 7C3, 7 times 6 times 5, divided by 3, 3 times 2 times 1. Remember combinations here? Doesn't this cancel with this? Isn't that 35? 1 out of 35. So you can use combinations, or you can use different events. These are dependent events, both of these. Or you can use permutations here. Your choice.